When you're graphing functions, it really helps to know some basic common functions, sometimes called parent functions. And the first one we're going to look at is a linear function. So I've graphed f of x equals mx plus b, and right now m equals 1 and b equals 2. M is the slope and b is the y-intercept, the place where it crosses the y-axis. So watch what happens when I increase b. You notice that the line slides up the y-axis. When I decrease b, the line slides down the y-axis. Now, what happens when we change m? Well, if you have a positive slope, the line gets steeper and steeper. It increases as we read from left to right. And as soon as the slope goes negative, it starts decreasing as we go from left to right. So those are the basics of a linear function. F of x equals mx plus b. Next up is a constant function. And this is always in the form of f of x equals b, where b is any real number. And here's what it looks like. It's a horizontal line, because no matter what x is, y is always going to be stuck at b. So if f of x equals negative 3, we have a horizontal line that crosses the y-axis at negative 3. If b is positive 2, we have a horizontal line that crosses the y-axis at 2. So that's called a constant function. The identity function is f of x equals 1x. So since there's no b, it goes through the origin, crosses the y-axis at 0. And since m is 1, it increases at a slope of 1. So this is the identity function. And every x coordinate matches every y coordinate because f of x equals x. So for example, you've got a point at 2, 2, and 3, 3, 4, 4, etc. This is a graph of a squaring function, f of x equals 1x squared. And you just put in values of x. So for example, if we put in, say, negative 1 for x, after I square it, I get positive 1. So I have a point at negative 1, 1. And when I put in positive 1 for x, I get positive 1 for y. So I also have a point at 1, 1. And at 2, 4, 3, 9, and so on. And what it creates is a parabola, and the vertex is at the origin. Here's the cubing function. And since when we cube a negative number, we get out a negative number, that means when I put in a number like negative 2 for x, I'm going to get out negative 8 for y. So there's that point there. And of course, positive 2 cubed gives me positive 8. So there's that point there. So this is in the third quadrant and the first quadrant, and it actually has origin symmetry. The square root function is f of x equals the square root of x, and since we cannot take the square root of a negative number, it starts at 0, 0. And here's a point at 4, 2 because the square root of 4 is 2. I'd also have another point at 9, 3 because the square root of 9 is 3. So it's just half a parabola going like that. The cube root function is f of x equals the cube root of x, and we can take the cube roots of negative numbers. So now we have points in the third quadrant as well as the first quadrant. So if I put in negative 8 for x, the cube root of negative 8 is negative 2, so there's that point right there. The absolute value function is f of x equals the absolute value of x, and since absolute values turn anything negative into a positive, we're only going to get positive y values here. So that means if I put in, say, negative 5 for x, the absolute value of negative 5 is positive 5. So I get a point at negative 5, positive 5. And likewise, if I put in positive 5, well, it stays positive. So I get 5, 5. And what we get is a V shape. And the vertex of that V is at the origin, 0, 0. And finally, the reciprocal function, f of x is 1 over x. Or you could say x to the negative 1 power. And this looks like it's touching the x-axis. It's actually not, okay? So we have a horizontal asymptote at the x-axis. It gets close to but never touches it. And x can never be 0 because we cannot divide by 0. So we have a vertical asymptote at the y-axis. So if you graphed this, it's going to look like this. You've got positive and negative. So for example, if I put in 2 for x, I'm going to get out 1 over 2 for y. If I put in 1/2 for x, I'm going to get the reciprocal of 1/2, which is 2 for y. And then the same thing happens in the third quadrant. So this has origin symmetry. Now, we can classify some functions as even functions and some other functions as odd functions, and lots of functions are neither. But how do we know if they're even or odd? Well, it turns out that functions that have y-axis symmetry are even. That means if I replace x with negative x and I get the same thing I started with, it's even. Functions that have origin symmetry are odd functions. That means if I replace x with negative x and I get the exact opposite of the function I started with, it's an odd function. So let's determine whether this function f of x equals x squared minus 3 is even or odd, or it might be neither. Okay, we're going to replace x with negative x. And remember that I'm squaring negative x. And when I square it, it becomes positive x squared. And that is exactly the same as the function we started with. So we can say that this function is even. And here's a graph of it, and you can see that it has y-axis symmetry. So y-axis symmetry and even functions go together. Okay, now let's determine whether this function g, which is equal to x cubed minus x, is even or odd. So I'm going to replace x with negative x. That means I'm going to have negative x cubed minus a negative x. Okay, when I cube a negative, it stays negative. And when I subtract a negative, it becomes positive. Notice that this is the exact opposite, the negative, of what we started with. We started with positive x cubed minus x. We ended up with negative x cubed plus x. Since our new function after we plugged in negative x is the opposite of what we started with, this function is odd. And let's take a look at this graph. Notice that everything that is happening in the first quadrant, go away. Everything that's happening in the first quadrant has an exact match in the third, and everything that's happening in the second has an exact match in the fourth. So when we have that kind of symmetry, it's origin symmetry. So odd functions have origin symmetry. Okay, last thing I'm going to talk about is something called average rate of change. And the average rate of change of a function between an x-coordinate at x1 and an x-coordinate at x2 is f of x2 minus f of x1 over x2 minus x1. Now I hope that looks a little familiar. That's like saying y2 minus y1 over x2 minus x1, which is slope. So the average rate of change is change in y over change in x. So let's find the average rate of change of this function f that's x squared minus 2x from x equals 0 to x equals 4. So here's x1 and here's x2. So we're going to do f of x2 minus f of x1 over x2 minus x1. Okay, so f of 4 is 4 squared minus 2 times 4. And I'm going to subtract f of x1, which is 0 squared minus 2 times 0. And that's going to be over 4 minus 0. Okay, so it becomes 16 minus 8 minus 0 over 4, which is 8 over 4, which is 2. So 2 is the average rate of change of this function as x goes from 0 to 4. Okay, I've got one last thing to talk to you about, and that's increasing and decreasing functions. So we're going to do this by looking at the graph of the function, and we're going to do three things. We're going to state the domain, the range, and the x intervals where the function is increasing, decreasing, or constant. Okay, so let's look at the graph. Notice that the arrow goes to the left and the arrow goes to the right. So our domain, all real numbers. What's our range? Well, it looks like it never goes below -1 for y, but it does go up forever. So the range is going to be from -1, including, so I'm going to put a bracket there, -1 to infinity. Okay, where is it increasing or decreasing? Okay, so let's check out increasing first. You read graphs from left to right. So as I'm going from left to right, it's not increasing. It's actually decreasing there. It's not. Okay, now it's increasing. It's increasing from x equals -1 to infinity. So we'll go, I'll put a parentheses there, -1 to infinity, because at -1 it's neither increasing nor decreasing, so we'll just put a parenthesis. Okay, where is it decreasing? Okay, these are all the places where it's going down as we read from left to right. It looks like it's going down from x equals -3 to x equals -2. So that's our interval for decreasing. Where is it constant? That means where is it flat? Where is it horizontal? I see two places. From -infinity to -3, and from -2 to -1. So that's how you know where a function is increasing or decreasing, just by reading a graph from left to right.